In this video, we are going to be talking about evaluating expressions using exponent rules. Now, we're going to look at 4 examples, and you're going to want a power table when we are working through these problems. So, looking at number 1, we are taking 4 squared times 4 to the 4th. Now, you will recall from our exponent rules that when we multiply like bases, meaning these big numbers are the same, we simply just add the exponents together. So we take 2 plus 4, which is 6. So we get 4 to the 6th power. Then this is where our power charts come into play. If I want to know what 4 to the 6th power is, my base is 4. So in the base column, I go down to 4. My power is 6, so I go to the 6th power, and I see where they line up, and I see that that number is 4,096. So this is equal to 4,096. Now, some students, the typical mistake that we will see on a problem like this is they will add the exponents together. So they'll take 2 plus 4 and get 6, which is right. But then instead of leaving the base as a 4, they'll take 4 times 4 and they'll put 16 here. They'll say 16 to the 6th. Now, this is actually incorrect. Okay, this is wrong. And I want to talk about why this is wrong. The reason why this is wrong is if we think about what exponents mean for a second. What does it mean to be 4 squared? Well, 4 squared is really taking 4 times 4. And if I think about what 4 to the 4th power means, that's really taking 4 times 4 times 4 times 4. So if I take 4 times 4 4 times and 4 times 4 twice, and I multiply those together, in total, I'm multiplying 1, 2, 3, 4, 5, 6 fours. I'm multiplying 4 6 times, so I get 4 to the 6th. Where 16 to the 6th would mean that I'm taking 16 times 16 times 16 times 16 times 16 times 16, which would give me way big of a number and is not equivalent to 4 squared times 4 to the 4th. So when we do this, when we're evaluating expressions, we don't multiply the bases. Okay, the base stays the same. We just simply add the exponents. Okay, we're just following our exponent rules. When you multiply like bases, you add the exponents. So keeping with this idea, let's look at example 2. So in example 2, I have 5 to the 7th power divided by 5 to the 4th. Well, when I divide like bases, I subtract the exponents. 7 minus 4 is 3, so I'm now going to have 5 to the 3rd power. Okay, once again, notice the base doesn't change. It was a 5, it stays a 5. It's just the exponents. I'm taking 7 minus 4, so I get 5 to the 3rd power. Now, once again, to evaluate this, if I want to know what number that is equal to, I need to rely on a power table if I don't have a calculator. So we want to know what 5 to the 3rd is. So my base is 5. I go over to the 3rd power, and I see it's 125. So this is equal to 125. All right then, moving on to example 3. Okay, here I have 2/5, and I'm taking it to the 4th power. Now, notice this rule is really the rule of raising a power to a power. Right now, I have an exponent of 1 on the 2, and I also have 5 to the 1st power. Whenever we raise a power to a power, we multiply the exponents together. So if I take 1 times 4, I get 4, so this is now going to be 2 to the 4th. And then when I take 1 times 4, I get 4 as well, so that'll be 5 to the 4th. And then if I want to know what this is equal to, I just use my power table to figure out what the top is equal to and what the bottom is equal to. So looking at the power table, if I want to know what 2 to the 4th is, base of 2, power of 4, I get 16. So 2 to the 4th is 16. Then I calculate what 5 to the 4th is. So I go 5 to the 4th, and I see that it's 625. So I get 625. Okay, so my final answer would be 16 over 625. All right, real quick then, one last example here. Here we have 2 to the 3rd divided by 3 to the negative 2nd power, all taken to the 2nd power. Now, once again, we're raising a power to a power, so I have to distribute this exponent to each of the exponents on the inside. And when we do that, we're multiplying the exponents together. So if I take 3 times 2, well, 3 times 2 is 6, so I'm going to get 2 to the 6th on top. And then on the bottom, when I take negative 2 times 2, I get negative 4, so that's 3 to the negative 4th power. Now, you'll have to recall here that negative exponents are equal to the same power on the other side as a positive. So what I mean by that is if I have 3 to the negative 4th on the bottom, that's really the same thing as 3 to the positive 4th power on the top. So the negative exponent will move up and it'll move off the bottom, and the negative will become a positive. Okay, so this will be equal to 2 to the 6th times 3 to the 4th. Now, 2 to the 6th, once again, I can look up on my power table here. So if I look up 2 to the 6th, I see that it's 64. So I get 64, and then I'm multiplying that by 3 to the 4th, and 3 to the 4th is 81. Now, it's likely that if you have these two numbers, and on your test, if you're not given a calculator, to do 64 times 81, you can use a calculator on that. If you don't have a calculator, for our purposes right now, it's okay to just leave your answer as this. If you want to do the algorithm and calculate out what 81 times 64 is, you can. But for the terms of this video, we're not going to worry about it.